Welcome back, and this is the second bit of content that I want to talk about for this lesson. And essentially, that's what happened after you make the product. So you make this product, and let's say you use it, and you're supposed to use it once. It's a disposable product. So what happened next? Does it go to waste? Does it get recycled? And how does it get recycled? What do you mean by recycle? What are we actually doing if we want to recycle this product? Does it go back to the pellets? Does it go back to propene? Does it go back to propane? How are we recycling this product? Are we recycling this product, or do we just dump it in landfill? What happened after it is dumped in landfill? Does it get decomposed? Can it degrade into anything else? Does it degrade back to anything? So the purpose of this video is to investigate what happened after you have used this product. Can you recycle it, essentially? So we're going to look at the recycling of plastic today, describe the differences, well, the difference with regards to structures and properties of thermoplastic. We're going to talk about thermoplastic and thermosetting polymers. I don't think we look at elastomers, actually. And we're going to describe how addition polymers can be recycled. I'm going to start with the plastic resin coats, which I think some of you, hopefully all of you, have seen at one point. And I do want to point out that if you see this symbol in your plastic containers or whatnot, this is not an indication that the plastic can be recycled. This is just a code that tells you what type of plastic is in the material. It's quite misleading because they all have like the 3 arrows for recycling, but some of them actually cannot be recycled. So if it is this and it has like a 5, that's polypropylene or PP. So if you see a little symbol with number 5 in your container, it's you know that polypropylene is in it. You can also have things like PVC, polyvinyl chloride, or PETE, very, very common plastic. And then if they can't really classify any further, just call it others. Others bad because definitely can't be recycled. So I'm just going to show you the rate of plastic recycling. This information was published in 2018, so I think it has changed, but unfortunately there isn't a very high percentage of recycling for any of the plastics. But you can see this one can't be recycled at all. This is 0% of recycling. So number 3 is not being recycled. Number 7 is not being recycled. What we were talking about earlier was PP, very, very low percentage of recycling. The one that is recycled the most right now is PETE, and then HDPE, and a little bit of LDPE. So what I want to talk about, and we're going to potentially touch on why the rate of recycling of polypropylene is so much lower, but at least you can. So you can recycle polypropylene, you can recycle polystyrene. So the first thing we're going to talk about is why is it that some plastic can be recycled and some cannot be recycled at all. So what are the properties that allow a plastic to be recycled and what actually goes into the recycling process? So let's talk about the plastic recycling process. So let's say you did your due diligence and sort your waste and you put all the plastic waste in the recycling bin. Allegedly, if this actually happens, I'm not going to go into any conspiracy theory or critique of anything, but allegedly, if this is done properly, it's going to, the plastic waste is going to be transported to a factory where the first thing that happens is you have to sort the plastic waste into the specific types of plastic. This is a very expensive and time-consuming process. You sometimes have to sort it manually. I mean, if we're a little bit better, we can use some other technology like you dissolve mixture. I'm not entirely sure how this works. I just saw it somewhere. Or you can use other specific techniques like infrared spectroscopy, but I'm not going to go into the details. So this is already expensive, time-consuming, tedious, probably not very effective. It would be much better if the consumers can sort this themselves and then you just go 1, 2, 3. Maybe that will happen in the future. So first step is to sort the plastic waste into specific types of plastic. So once you have had the specific types of plastic, each of these, let's say number 1, for example, is going to go in here when it gets shredded into smaller parts. And then you need to wash the small plastics, remove all the contaminant, and then decontaminate it. So basically what you want from out of all of these processes is just the pure, if pure is what, you just want the pure polymer. You don't want, or plastic, you don't want any dirt, you don't want any residue ketchup in your ketchup container, you just want the plastic. And once you have the plastic by itself, and I do want to point out that these two steps, again, very expensive, time consuming, tedious, that's the same as time consuming, and not efficient at all, and sometimes potentially very dangerous depending on what is in the plastic in the first place. So because this takes so long, a lot of the time people don't even do it, and that's the reason why plastic is not recycled properly. But once you get to the pure plastic, what you actually do next is very similar to the production of the pellet. So you're just going to melt the polymer materials, the pure plastic. We talked about this before when we look at production of pellets. So you're going to melt the waste plastic again and convert it again into plastic pellets. And the plastic pellets could then be reused for to make new plastics, if you will. Obviously, you have a lower degree of control in terms of what size the pellet is going to be. It really depends on the plastic that you melt. So you can't really use these pellets for any specific, like very sophisticated product that requires a specific chain length or specific stacking. But you can use it to make, I don't know, tote bags, shopping bags, which, we don't care too much as long as it holds and it doesn't break. So there is limitation in terms of what can be produced from these pellets, these recycled plastic pellets. Okay, so that's that. That's the plastic. That's one way to recycle plastic. This is the most common method. This is the current method for recycling plastic. There is another way. I'll talk about it later, but that's that. Easy. But in order for plastic to be recycled, because you have to melt the material so that you can make the plastic pellets again, in order for that to work, the polymer must be what is called thermoplastic. We really need to stop using the word plastic. I feel like watching Mean Girls again. Okay. Thermoplastic means that the polymer can be melted into a liquid at higher temperatures, molded, and then solidified once cooled. So thermoplastic polymer, you can melt it and then you can cool it and it's not going to degrade into anything. A polymer would be thermoplastic if the chains are held together by weak intermolecular forces, especially if it's dispersion forces. So there are degrees of thermoplasticity depending on what kind of intermolecular forces are within the chains. Melting the polymer involves breaking of the intermolecular forces, which can be reformed when the polymer is cooled. So for example, if I have something like polypropylene, because it is hydrocarbon and non-polar, it's not going to have any other types of forces between the chains beside intermolecular dispersion forces. So you basically have dispersion forces between the chain. So let's say this is a solid form, so this is dispersion forces, and this is solid. So what you do when you melt it is you just apply temperature. You don't really high temperature. You don't really need the temperature to be that high because you're just trying to break the dispersion forces to separate the chains. So they're going to be further apart from each other, like this, for example. And they will have, so this is the liquid form, but they still remain intact. You still have the chains, and the temperature that is required to break the dispersion forces are significantly lower than the temperatures that would require to break the chain. So you can melt the material without breaking the actual polymer chain. And if you cool it again, when you turn them into pellets, so you can pour these molten polymer into pellet molds, and then when you cool them again, and I really need to copy and paste if I could, but anyway, then they're just going to come together once more, and then they're going to form dispersion forces again, and so you can do a lot of things with it essentially. So thermoplastic polymers are really useful in this way. You can definitely recycle because you can heat it up and cool it down for as many times as you want, and it shouldn't affect the chain. So this is once again dispersion forces. So anything that has weak intermolecular forces between the chains would be considered a thermoplastic polymer. Obviously, if the intermolecular forces between the chains are dipole-dipole interactions, if you have a polar group in the polymer, then the temperature required to melt would be higher, but it's still nowhere near as high as the temperature that would actually degrade the chain. So there are some polymers that are not thermoplastic, and they are called thermosetting polymer. And what the name is trying to tell you is it's set. You can heat it once to make it, but you can't heat it anymore. The second time that you try to melt the polymer, it's going to degrade the polymer completely. It cannot be remolded with heat. Therefore, the polymer cannot be recycled back into pellets. So you cannot I'm not going to say that this polymer cannot be recycled at all, but it is a lot more complicated to recycle this polymer. So thermosetting polymers contain some covalent bonds between the polymer chains. These are normally called cross-links. So if I'm just going to give you an example, let's say I have 3 chains here, and you still have dispersion forces or other types of intermolecular forces between the chain. But the difference between thermoplastic and thermosetting is you actually have covalent bonds between the chains as well. And how many covalent bonds you have depending on the polymer. But these are called cross-link. And they are essentially covalent. So if I want to move these chains far apart from each other, the temperature that I would need to do that is really, really high, because I basically need to supply enough heat to break the cross-link, which is a covalent bond. So by the time I supply enough heat to break the cross-link, that temperature is high enough to break even the covalent bonds within the main chain. So you basically just break everything. So you break that, that's good, but you also break the chain itself, because the temperature that you supply is enough to break covalent bonds. We're talking thousands of degrees here to break covalent bonds. So if you melt the polymers materials, it's just gonna break apart, and you can't really convert it back. If you cool it, it doesn't just reform the covalent bonds, so you can't really, it just degrades basically, and you can't really recycle it. So that's the issue with thermosetting polymers, is if you see a polymer that has covalent bonds between the chains, it's going to be very, very difficult for it to be recycled. If I would say it would not be possible for it to be recycled back to the pellets, because you can't melt it and then cool it and remold it. An example of thermosetting polymers is vulcanized rubber. This is why you cannot recycle car tires, because it just breaks apart. And you can see here, so you have a different covalent link between the chains than the one within the chain, but they're still covalent. This is the SS disulfide bridge. I assume that the bio people would know what they are, but apparently not. So I'm not going to say the bio people have seen this, but it's in proteins. So that's thermosetting polymer. Other issues with recycling, what I've touched on before, is the issues with this process. The washing, the contaminant separation, and the decontamination process is too complicated, too expensive, too time consuming. And this prevents the material from being recycled, because it's just not worth the effort, or people don't have the money to set it up properly. So those are the issues. So if you go back to this diagram of the mask, now the mask is made from polypropylene, but there are at least 3 types of polypropylene fabric. And if you have multiple different types of material, it generally means that you need different melting temperatures. So you need further separation of the 3 different types. If you melt all 3 in using one temperature, then it tends to not be as effective. So there are 3 types of polypropylene, at least, materials in here. So that already make it quite hard to recycle. And also, this is a medical plastic waste, and as of now, we don't really have very good protocol for decontaminate it and separate it from whatever it is on it, some bacterial virus. And especially after this pandemic, we're going to have a mountain of waste, mountains and mountains of N95, use N95 masks. And I actually don't know whether anyone has thought of what to do with the waste. Are you going to just shift it to landfill? Is it just going to end up here? Is it just going to end up here? Because this is the current fate of these medical waste and the N95 mask in particular. So even though it has polypropylene as of now, it's not considered plastic. You cannot put the N95 mask or any medical waste or any face mask into the plastic recycling bin yet, even though it has the plastic in it. So maybe one thing that we're going to do is we're going to see whether we could recycle this and put it back into polypropylene. Essentially, you melt it, so decontaminate, and then you melt it, and then it goes back to polypropylene. But this part right now is blocked. And I did tell you that there is potentially another way to recycle, and that is under development. Let's use another color. Hang on. So what's a good? Let's be hopeful and use blue. So there is another way that you potentially can recycle, and that is here. So you can bring it back to the monomer, and this is called depolarization, depolymerization. This is even more expensive than this method, but basically you want to cut the polymer and bring it back to monomer. If you can bring it back to monomer, it allows you to do so many other things, because if it's now the monomer, you could make very, very specific products again, or you can even use it to make something that is not plastic. Well, actually no, it's always going to be plastic. You can use it to make other things as well. Actually no, you can use it as a fuel. Propane is a fuel. So under development. But if we can recycle plastic via depolymerization, so just convert the polymer back to the monomer, it means that the recycled plastic can have a lot more usage after, well, compared to what you're currently doing now, when there's a lot of limits in terms of, again, my English breaks down today. There are a lot of limitations when it comes to what you can do with the recycled plastic if you just bring it back to here, because this pellet has less control in terms of size, chain length, and things like that. Another good thing about depolymerization as a recycling method is you could also use it for thermoset polymer. So if I have thermosetting polymer, the things that cannot be melted, if I can depolymerize it, I can also recycle it. So thermosetting polymer could also be recycled via depolymerization. So this is just under development. Hopefully in the future we can have better recycling methods, because right now this is such an unsustainable process. It's not even funny. Or another thing you can think of is, let's say, okay, fine, I put it in landfill. Is there anything that I can do after landfill? Can I degrade it? Will the product biodegrade into carbon dioxide eventually, so it's not gonna stay there for hundreds and thousands of years? As of now, it doesn't. It will stay there for hundreds and thousands of years. It's not biodegradable. But can we make this mask using a material that will degrade eventually, so you can put it in landfill and not feel too bad about it? And I'm not even going to talk about the rubber band, because that's another issue. So this is something that you really want to think about as citizens of the 21st century. Any catchy phrase, any inspirational quote, slogan that you can insert here, just feel free to do so. But I think it's really important to understand where a product comes from and where it would go after you finish using it, because there's not a lot that we're doing with recycling, so everything just go in landfill and we don't think about it. But hopefully after this whole shortage of one type of plastic, we think a little bit more about whether we can make the product more sustainable. Anyway, I'm gonna stop now because I started rambling. That is it. I do want to point out, I don't even know what that is. I do want to point out that there are other types of plastics that we haven't talked about. So I'm going to give you some questions on these two, HDPE and LDPE. So that's the worksheet. So make sure you do that and see whether you can apply what you've just learned in another context using another plastic polymer.